Hey students, we are going to jump into 14.2 with a couple of questions. Let's take a look. First one was 14.2, number 14, part C. Now in part C, you'll notice it says x equals 0. And I think that's probably where the issue might have come from, because when you think of all the other equations, everything seems to be okay. But like y equals 3x, then maybe you're even busy saying, well, I can do that. I can make like a quick little table. And if x is 1, then y is 3. And if x is 2, then y is 6. And that works really well for something like this, where y is equal to 3x. But what do? There's no y in the second one. And I just want to remind you what that means in mathematics is if there is no variable, then there is no restriction. So you could still do this same type of table, pick whatever you want for y. Let's just say we pick y equals 1, and then what is x? And x is 0. Okay, well, let's say y is 2, then x is 0. And what you really understand about this equation is it does not matter what the y value is. The x value has to be 0. So 0, -2, 0, 17. And that's the way this one works. So when you're graphing it, if you kind of want to see what it looks like, right? Maybe that's also part of this, right? So let's get a little white space over here, and let's do a quick little graph. So if we gave like an x and a y, here's an x and a y. So then I want the point x equals 0, y equals 1. Okay, there it is. Maybe put some check marks here. There we go. Okay, so x equals 0, y equals 2, right there. 0, -2. Okay, right here. There we go. So what are you noticing about these? You're noticing that these points that we're creating are all located on a particular line. Each one of these is a line. And so this line happens to be this vertical line. If you're reflecting it over the x axis, that's this one, what will you get? What is the equation of the result of that? Okay. All right. So there goes that. Let's see here. Oops. I just stopped sharing. Sorry about that. That was my It's a good day when you stop sharing right in the middle of doing some questions. I apologize for that. Okay, let's take a look. Next one, I believe, is an MC, and we're going to go to MC number 3. So let's jump forward a little bit. MC number 2, MC number 3. Here we go. Okay, and we've got y is A prime the reflection, y is A prime the reflection of C in MD. Okay. So when you're talking about reflections, remember a couple things. They have to be perpendicular and they have to be the same distance, just on the opposite side. So when you look at this shape and you remember how we did this, these are midpoints, right? They're midpoints. So that means when you have triangles that this length is the same as that length, and this length is the same as that length. Or perhaps better said, the first segment here to the bigger segment is in a ratio of 1 to 2. Same is true over here. And there's an angle between that works, which means we have similar triangles, right? This top triangle here that I'll put kind of in red, and then I'll do a different triangle in blue, this outer larger triangle. Those triangles are now similar triangles. So this came up back in, I believe, chapter 12, when we had midpoints and created similar triangles. So this is by side angle side. We have two proportionate sides. They're all 1 to 2. And the angle between them, which is angle A. So that means any relationship from one triangle to the other, lengthwise, will have this ratio. So what they're going to do is they're going to say, well, let's take a look at the height here. Think about this height, which is perpendicular. And then consider, there's another one right next to it, the one that goes from A all the way down to this side, this height. And you can see it did have a right angle there. Okay, well, those have to be in a ratio of 1 to 2, which means the dark green line is twice as long as the black line. Another way to say that is if you were to reflect over the line MN right here in the middle, that this black line will flip over and become a black line here and also be perpendicular. So what does that tell you? The point you started with up here will reflect over and become the point down here. So why is A prime the reflection of A in MN? So why does a flip over MN of point A equal point A prime? You can say because similar triangles. The ratios are going to be the same, 1 to 2. So this height on top has to be the same on bottom. And it's pretty similar in terms of explanations for some of those other components. I'm sure that they would ask you, if they don't, they're kind of silly. This is what I would ask you. I would say, look at this triangle, right? Well, what kind of a triangle do we have, right? So as you look at this, and you can say points D and E are points of perspective to the perpendiculars of M and N. So I have a perpendicular, right? And let's see here, what else do we have? So when we folded this side, I'm going to squiggle it. Let me choose a different color so I don't, that looks a little, I'm going to squiggle this one. Remember this one? A moment ago, we said it was the same length as this, right? Yeah. And these are intersections of the perpendiculars from M and N. So what you have is when you reflect MN over, then the purple line you had up on top becomes this line right here. It flipped over. So I have a right angle. I have a leg that's the same, that's the middle, and then I have the hypotenuse. So we have hypotenuse leg. The two triangles sitting right over here, this one, which is on the left, and this one, which is on the right, those two are, yeah, those are actually congruent triangles. Not similar. A moment ago, we had similar triangles. These are congruent triangles by hypotenuse leg. And if you've got, oops, let me get rid of those drawings. And if you have hypotenuse leg, then you get something else. You get corresponding parts of congruent triangles are congruent. So this segment has to be the same as that segment, which means if I was to reflect over MD, and I was going to take point C and reflect it over MD, I have to get point A prime. There is no other place for it to go. So the justification that we're looking for in the MCs, again, it's math connections, right? So we're connecting this back to what we did in chapter 12 with similar and congruent triangles to demonstrate to someone why this has to be the case. Okay, let's take a look at what did they say. A prime is a reflection of A is a reflection of C. Yes, explain why this angle is congruent, this angle is congruent, that angle is congruent. Okay, well, that's very similar reasons. And what property of angles follows? And hopefully you can kind of see the big idea of something like this. This actually goes back, where was this? I think this was chapter 11, but I think we also saw it again in chapter 12. The idea that this angle up top, it flipped over, so it becomes this angle down here. And the angle to the left, right there, becomes this angle right here through a reflection, through paper folding, if you will. And this angle right here becomes that angle right there. And so what you have is, yes, you do have 3 angles right here. And we know what that becomes, straight line. And notice those 3 angles are also conveniently located on this shape. So again, this goes back all the way to chapter 11 when we were talking about how do we know the sum of the angles is a certain number. So again, that's kind of the big idea here. Now, again, the reason why we're doing this is, yes, we already did show this picture, but we never looked at this picture with the idea of what does that fold do? Now we have the language of transformational geometry, the idea that folding it preserves angles, folding it preserves distances. So when we have distances preserved, we get new congruent triangles. So we're doing what we did in chapter 11, using similar and congruent triangles from chapter 12, while the language and notation comes from transformational geometry in chapter 14. And that, my friends, is why they call it a mathematical connection. All right. I hope that works for you. Off you go.